Okay, so this is the second lecture for March 1st, 2017. I'm going to talk about data modules, continue on with data modules. Specifically, we'll start with resource data modules. But again, the data module is a module much like any other module, except it's not connected directly to any other modules, meaning that it sort of covers or is over the top of the entire flowchart and isn't attached to any specific module within that. So the data module, again, typically would be edited through the spreadsheet. If you look at the resource data module, there's a number of options that can be edited. The type first, you can base the data module on a number of different things. One would be a schedule, or another would be fixed capacity. So you can pick that type. You can pick what the capacity would be in terms of number of units. If I have a resource, again, if we go back to our manufacturing examples of a drill press, the number of drill presses I have and or the number of drill presses available in hours per day. It can sort of be spec'd out in either way. And you can do that a number of different ways in terms of availability. But in any event, it's capacity in terms of hours available for that resource. Failures, again, to define cause a resource to fail according to some pattern, and you would typically do that through the failure data module, which essentially is if that resource goes offline for some reason, what do you want to do? And that we'll talk about later when we get to the advanced process panel. But effectively, if I have a failure of the resource, it goes down for some reason, how do I want to respond to that is what's being talked about there. So the next one we'll talk about is the queue data module. And again, it's a data module, so it's not connected directly to any specific process or any module within the flowchart. But typically it is assigned to a specific. In the case of the queue module, it's assigned to a process. An example would be if I, again, have a drilling center, I would have a file called drillingcenter.queue, which would give me basically what's in the queue. And that type that we look at, the queue discipline or ranking rule, and that is, again, is that a first in, first out thing, or is it a low, medium, high kind of attribute thing that we look at? And there's a bunch of different ways you can do that. Setting priorities, as well as looking at an attribute. And again, the attributes are specific to entities. So I can look at an attribute that I've assigned to an entity and then make a decision on that, on where that falls into the queue. Does it go to the front of the line, or does it follow priority, or what methodology or construct am I using to put that entity in the queue, and where does it fall? Shared queues are something that we'll talk about later. And we'll get to that when we get to advanced processes. And then finally, report statistics. So that's just a question that's being asked. Do you want to report statistics? And typically you would. You want to look for things like queue length, average time, and many times, more importantly, the max time in the queue. So that many times is the most important thing. If you're looking at things typically outside of manufacturing, like toll booths and fast food and security lines at airports, things like that. It's many times more important what the max time is than what the average is. If the average is 5 minutes or it's 7 minutes, probably doesn't matter too much. But if every once in a while you get a max time of 3 hours, that's going to be a problem. So that's, again, something you would typically check report statistics. I can't think of a reason why you wouldn't want to see that. Pretty much every simulation that we talk about, that is an important aspect of it. So the animation for a queue is the symbol there that you see on the screen, sort of the horizontal bar with a shorter vertical bar at the end of it. And what that does is basically just show you graphically what's in the queue up to a certain point. Once you've exceeded that length of that horizontal bar, then they're still there, but once it's maxed out, that's all it shows. So this is the place where we talked earlier in the last lecture about our entity pictures, or how they're graphically depicted. I think for the most part, it's easiest just to pick a simple shape. a ball and then just change its color is good, or you can pick other things too. But to try to get something that actually represents what's in your physical process is pretty difficult with Arena at this point. There's not really a lot of options there. So picking a simple entity picture and then changing its color or changing its type, depending on what's happening to that specific entity, is pretty useful. I mentioned this earlier. When you're doing a simulation and you're running it fairly slow, and you're trying to understand what's happening within that simulation, changing the entity color and/or type based on what's happened to it, what loop it's going through, for example, what happened to it in a decide module. Has it been told to go to a specific process? Whatever it is, to sort of show that change. Resource animation doesn't come sort of automatically with Arena. You can do that by plugging in a picture of some sort. We're somewhat limited with the student edition as to what we can do with that, but you can do some things, and you can show the picture in a couple different states. So you can show it in an idle state. Typically, you'd show it in an idle state and a busy state, and you change that picture to reflect that. So again, useful when you're doing a simulation. Again, just gives you sort of a graphical look at what you're actually what's actually happening within the simulation. Your Disclose flowchart module, again, so this isn't a data module, but it's a simple, it's similar to your Create module, except it's at the other end of the simulation. And essentially all that's happening with this is it's just a way to let the entity out of the simulation. So it doesn't continue to loop in some way inside of it. Typically you'd name it. You may have, and reason being is you many times would have multiple Dispose modules that would be different paths, maybe accepted parts and reject parts. Could be other things as well, depending on what your simulation is, if it's a manufacturing operation or something other than that. The only real thing that you would look at or use this for is to what statistics about the process do you want to collect. And typically you want to collect certainly the average time in the system, which is the time from entering through a Create module to exiting through a Dispose module. Number of entities exiting. If I had, for example, a manufacturing process and I have a ship to warehouse or ship to customer Dispose module, as well as a scrap Dispose module or rework Dispose module, I'd want to record the number of entities that are exiting through that specific module, which would be certainly helpful in analyzing the process. So typically the only thing you're going to do here is record statistics of entities that leave the system. So again, connecting, this is a bit of a review. Simple, straightforward, number of ways to do it. There's an auto connect option. Many times it's just as easy to connect it manually, but in any event, you simply connect the object connect and pick the tail of one process and connect it to the entry point of the other process. Typically is what you do. So that's just connecting up your flow chart. Basically, that's a flow, if you will, of the entities through the system. Pretty straightforward. And again, auto connect, smart connect sort of picks what it thinks you want to do. Any of these work just fine. And again, it's just connecting the entry and exit points of successive, or, well, not necessarily successive. They wouldn't have to be. They could be any modules within the system. You can have a loop, like a reject loop or a rework loop rather, that would connect an output of one module, could be a decide module, for example, up to something back up in the system, even 3 or 4 layers back, to rework a entity that may have a defect to it. And that's a great example where you would probably also use an assign module, where you would change the entity picture, as well as maybe change an attribute about that, or assign or change an attribute about that specific entity, which would allow you or facilitate collection of data, as well as by changing the picture, you get a good graphic of what's happening. So that's a very useful thing to do. So some of the plots you can run dynamic plots. In other words, you'd have a number of different graphing techniques that you can use to, in sort of real time, watch things like queue sizes or processing time, and you can embed that right into your flowchart, right adjacent to your flowchart, and it would, in real time, essentially, as your simulation is running, it would show you the disposition of an entity, or possibly some value associated with that entity being an attribute or a variable for the system you could look at as well. So can be useful depending on what you're trying to do. If you're trying to look at queues and sort of graphically see when did they stack, when did they start to run out of control, that can be a useful thing to do. Right? Because again, the queue on a process, once that little horizontal bar is full, there's a number that's displayed down below the process, so you can get some sense of how many parts are in the queue, or how many entities are in the queue rather. But sometimes a graph can highlight that better. The other thing you can do, which is useful, and we'll try to do this maybe in the next session, is you can put a number of plots in there. If you're trying to look at the effect of something in the process, say it's a statistical distribution, and you want to sort of look at that in terms of entry time for an entity through a create module for a given statistical distribution, and how that impacts a queue further downstream. You could put together a dynamic plot where you would look at both of those in conjunction with one another, and get a really good visual, good graphic as to what's exactly happening. So useful tool. And again, just a little bit more about that. I think it's fairly straightforward once you get to it. It's much like any other graphing program, Excel or whatever, that you can set various things. You set your axes, what variables you're putting on each axis, whether it's versus time, which is fairly typical, or you can actually plot a couple of variables against each other, if you will. So very useful tool. Drawing objects from the draw toolbar. This is something we've not really spent a lot of time on, just because it's sort of snazzing up your presentation a little bit. Not really all that useful to be for what we're doing here. If you're making presentations in front of a some sort of industrial or commercial enterprise, and you're maybe making a presentation with people that maybe aren't familiar with the process or familiar with what you're doing, that can be useful. But we've not spent a lot of time on that. But in any event, it's pretty straightforward. You can input DXF files from AutoCAD. You can import Visio files, which is used a lot for flowcharting. We are somewhat limited with this because you only get one graphic from each category with the student version. So that's a change that they've made with this latest update. So they added a bunch of stuff, but they don't give us access to that as a student. So, but anyway, it can be useful again. So then finally we get to where we want to run things, right? So we've got a number of things that we set. We've got our project parameters all set up and described. We'll go in and set up our replication parameters, which is under the setup menu, as you can see from the notes there. So that's one place I can input my number of replications. Sort of does the same thing as limiting the number of entities into the system. Pretty much does the same thing, sort of just a different place to do that. You can look at various initialization options between replications. You can set things like start dates and times to associate with the start of the simulation. And that would be maybe looking at warm-up periods is probably the best place I can think of that would be used before equipment can be pulled on. The important thing here too is your base time units. Make sure that they are the same, although Arena has the capability of adjusting between them. I've seen instances where it sort of gets a little confused on that, or out of whack on that. So it's best just to keep them. If you pick hours, use hours all the way through. If you pick minutes, use minutes all the way through. And again, it depends on the process. If you've got a process that takes a minute to run or half a minute to run, you're probably going to stick with minutes. If you've got something that's a longer process that takes hours, then you use hours. Whatever's more appropriate for your given application. Animation speed is something as a slider bar up on the top horizontal toolbar. You can slide that back and forth and pick And you can adjust animation speed actually while you're running. So when you want to see things, like again, if you've got multiple entities of different with different attributes to them, and you've assigned different pictures to them, so you can see sort of how they travel through the system, it's many times useful to slow down that speed so you can watch it basically go through decide modules, make its decision where it's going to land. How are the queues behaving? Are we first in, first out? Are we priority based? Are we attribute based? And make sure that all that logic that you've input works. But then once you get that done and you're satisfied that your logic's good, then you typically crank that animation speed up so it runs quick. So you can run lots of replications with minimal amount of time. You don't want to sit there and watch necessarily your animation run for 20 minutes at a slow speed. Once you're satisfied that your logic and the behavior of the entities within the simulation are what you're looking for. So again, that slider bar is very useful. You can just grab that, crank it up, or crank it back down if you're trying to look at something. And again, you need to figure out how to terminate it. You need to either put in a number of replications in your setup menu, or in your create modules, put in a number of entities into the system. The only sort of difference between those is if you've got multiple create modules, you have to enter number of parts that you want to come into the system from each. And those may be different. You may have 2 bolts and 2 nuts and 1 plate that's being fastened to something with those fasteners. So that's sort of the only difference. You can use either one, but number of replications is number of replications of the simulation. So if you've got multiple create modules, that's probably a better way to do it, but you can do it either way. It doesn't really matter too much. And then just crank it on. Hit the run module, off you go. The stop module gets you out of the run mode. You can pause it and then continue on. Again, the slider bar being mentioned here, that's very useful to speed up or slow down the animation. And then finally, what we're really after is to some extent the behavior of the simulation, but also of equal or more important in some ways is viewing the reports. And this, you look for a number of different things, and it's really dependent on what kind of simulation you're running, because the characteristics or the output of that simulation, depending on what the physical process is, the things you look at can be very, very different. And again, the example I've used in a manufacturing operation, I'm really looking at throughput over a given time. That's my most important thing. And if I wind up with, within reason, some queues building and then depleting and building and depleting, I probably don't really care that much. I really just care about what my output per unit time is out of the entire process. Where if you're looking at something like a toll booth or fast food or urgent care, I can't have a maximum time that's way out of bounds. I can't have a serving time at a McDonald's that's 4 hours, even though my average is 5 minutes. Where in a manufacturing operation, that's probably okay, assuming I've got room to store those parts that are getting built up on a temporary basis. So it very much depends on the characteristics of the physical process as to what reports or what characteristics within those reports I'm going to focus on. But basically everything about the simulation is in there somewhere in terms of min, max, average queue time, min, max, average processing time for each process, as well as for the entire simulation. Number of parts in a queue, max, min, average again. So time, parts, processing time, resource utilization. Again, it would be another thing that you would look at in many different simulations, manufacturing certainly being one. Am I resource starved, or what is it? Is it a statistical processing thing? In other words, that my cycle times in successive processes are not compatible, or is it that I'm resource starved? So those are all things that you can look at in the reports, and again, pretty useful information. And again, this is just going through some of the things you would look at, wait times, processing times. The other thing that's useful, especially from a manufacturing operation, is you can assign whether something is value added or not value added. And again, the example of that, moving things between 2 processes, not value added. Executing within that process, in other words, drilling a hole, milling a part, molding a part, whatever it might be. Those are all value added. In other words, I'm increasing the value of the part. When the part is out of that operation, it's worth more than it went in. So that's a useful thing, especially on the manufacturing side. And again, the number of statistics, it can be a tally, in other words, a count of average, min, max for discrete numbers, number of entities passing through the system type of thing. Time persistent type stuff where we're looking at time averages, max, min, where the time is a factor, Q time, things like that. And then finally counters where I'm trying to sum something, which could be, say I've got a reject loop through a manufacturing process. How many parts got rejected, and that would be an example of a counter type application. And again, you can also define your own user specified data as well, if there's something not in a standard package that's used. So the underlying software or database, I guess, really, with this is the MS Access database, Microsoft Access database, that Arena writes to as it runs. And you can do an awful lot with it right through Arena, but you can also look at it with other packages that allow you a little bit better ability to query that database and pull data from it. So we've not done much of that. We've just used the Arena package. It's pretty powerful as it is. But if there was some things you wanted to look at that or analyze or sort of sort through the data in a different way, you can use some of the standard Microsoft Access database packages to do that. The other thing we get is a plain text sort of summary report of what we've got. Underlying Arena itself on the simulation side is a package called Seaman, which is used, which is sort of the underlying kernel of what drives Arena. And that's beyond what we've gotten into with the course. That's again, sort of an advanced kind of situation. We've not had any occasion where we've needed to jump into that language. The thing we talk about too, though, is confidence intervals. We want to make sure we've got confidence in the data that using a t-test or other statistical validate or verification methods that in fact our data sets are valid. Okay, so we're going to look at a couple of examples here. One is an electronic assembly and test system. And we're going to look at another one then where we enhance that a little bit. We add some schedules and some states and some failure modes to it, which makes it a little bit more realistic or useful. And then finally, we're going to look at some of the enhancing animation capabilities. Again, I mentioned we don't do a whole lot of this, but at least some of the more useful things that some of the things I consider a little bit more practical, like changing pictures of entities and whatnot, so I can more easily track them graphically through the system. And then finally, looking at adding some travel times, some stations, transfers, routes, and animation of entity movement. This can be fairly helpful. And then looking at ways to find and fix model errors, which is always going to happen. The key point there, which I'll keep harping on, is keep your first iteration simple. With a simulation, get something that'll run. Sort of similar to writing code, if you will, software. Code is keep it simple. Start with something that you can get to run and then build on it. The other key point I'll make there is save and save often. And as you get to various points, if I'm starting with a simulation and I've got a fairly simple simulation, I need to expand it to make it useful. But that simple simulation, save it, and then take that file and file it with a new file name or new revision to it. So you can always go backwards if you need to, or drop back a revision if you wind up with something that crashes the system. And Arena, like fairly common with software, there are occasions where you'll corrupt a file and you can't easily get back to where you started from. So it's a useful thing to do, is maintain some string of revisions as you make changes. So we'll look at a couple different things. The input analysis is how are entities coming into the system? What's the distribution, or what are the parameters surrounding that? And we talked about this with the create modules. Is it a constant? Is there an equation of some sort or an expression, or is there a distribution? Or is it random? Is it deterministic? Those are things we look at. Collecting and using the data. Obviously, that's probably the most important thing. Is collecting, analyzing, and using that data so we can make decisions on the physical process. Okay, that's sort of the whole goal here. And then looking at fitting input distributions. Arena has an input analyzer that helps with that. So we've not up to this point gotten a whole lot into that, but we may try to this semester because I think that may be a useful tool. What that does is it does some correlation tests, t-tests, and other things that allow you to look at a distribution and determine, in fact, does your data actually fit that distribution? So that can be some useful stuff. The key point again on doing simulations is if you have data, use it. If you don't, you need to pick a distribution or some other methodology to determine processing time as well as input time, which is what we're discussing here. So if you have data, use it. That's sort of the key point, and then try to model using that and or a distribution which you determine to be a reasonable representation of that. So anyway, if we look at a typical electronic assembly system, again, my create modules, I've got, and this is just a piece of it. I have no dispose modules here, so it's just a piece of it. I've got two parts that are arriving into the system, both of them with an exponential distribution. Part B in batches of 4. So what this is sort of telling you is for every one of these, I use 4 of these, which is fine. And you bring that in batches of 4. As I mentioned, this really is the same thing as having a create module and a batch module following it. This just simplifies it, and it's all happening in one module, so it's a good thing to do. And the exponential here has a value of 5, here has a value of 30. So I bring that into a process and I establish some distribution for that, in this case a triangular distribution. The three numbers you see after it, 1, 4, 8 and 3, 5, 10 on the bottom one, represent the min, most likely, and max processing times for those distributions. So in this case, we're coming into a sealer, which is a single process. I'm bringing two parts in to it, and I'm sealing them together. Again, part A work is best approximated by a triangular distribution. Again, min 1, most likely 3, max 4. Part 4 with a Weibull distribution with its associated parameters here. So that's a sealing operation coming out of that, and this is sort of a contracted version of the flowchart, if you will. You would need a batch module here, and you would need a separate module out here, and then a decide module. That's all sort of been combined in this flowchart, at least, into a sealer process. But we would need to break that up a little bit in Arena to get two parts in a combined situation process, and then finally exit, and then make a decision on what's coming out. That this would be a simple decide the way it's been defined here, at least by chance. I've got 91% being shipped and 9% being reworked. Again, another process, exponential distribution. And then coming out of that, I would have another decide module. So again, this has been sort of condensed a little bit to show really the logic and the flow, not so much the mechanics of doing it in Arena. But in any event, this sort of gives you an idea of what we're looking at. So again, we got the arriving parts, processing to them, a rework, sort of an embedded decide module, an embedded batch module, and then finally your decide module at the exit, deciding between scrapping and salvaging and shipping. So again, if you look at part A, it's an exponential distribution, value of 5. From there, it goes to the part A prep, which is the process, again, the triangular distribution, then to the sealer, and then rework if they don't make it Through the rework, they get scrapped. And again, those are decide modules, in this case, all by chance. By chance meaning that I've defined a probability of a part being true or being good, or however I define it. Basically, you've got two paths coming. Well, actually not. You've got multiple paths potentially. N ways by chance. In other words, you've got a number of different possibilities. You could have 5 different paths coming out with different percentages in each one of those paths. In this case, we're just showing 2. There's just 2 options here, but there could be multiples coming out of each of these decide, sort of embedded decide modules here. So part B, again, we've batched that up. We've got batches of 4 coming into the process, which certainly would imply that for every one of these, I use 4 of these, and they get sealed together, and that becomes my finished product, whatever this electronic gizmo might be. So once arrived, the parts batch breaks into 4 individual parts. Okay, so that they're sort of embedding in here a separate module as well, and then proceed to the part B prep area, finally go to the sealer, and then finally my rework and embedded decide module. So my run conditions, the way this is set up, I start empty and idle, and then I run for 32 hours. So that's sort of my replication number, if you will. You can specify that by number of parts or time, either way. Whichever is more representative of your process would be how you would do that. And then finally, again, we collect statistics for each work area. Resource utilization from a manufacturing standpoint is typically a very important characteristic. Numbers in the queue, min-max average, and then time in the queue, same min-max average type stuff. So from a manufacturing standpoint, probably resource utilization, assuming these don't cause floor space issues where I've got too many parts in a queue, resource utilization is probably the most critical. Because again, that resource is a cost per hour to me, and I want to utilize it to its maximum so I can reduce my manufacturing cost as we go through this. Again, we collect time. We've got all these exit points shipped, salvaged, and scrapped. We collect those times in the system. In other words, the cycle time in the system with a manufacturing operation, and with other things too, is typically called a cycle time. So that's the cycle to get through the process. So again, this is sort of a general thing. This is not really specific to Arena, but it's more just of a modeling approach, and that's I found this to be useful. Essentially, developing that modeling approach consists of defining the pieces of the model, the modules, the data structures, and the control logic. One of the things that needs to be, which we've gone through all those pretty much, those basic components of a simulation package. One of the things that needs to be decided fairly early on, to an extent, although you can expand on this. This is sort of my comment earlier about keep it simple to begin with, get something that runs, and then add detail to it. And ultimately, you need to make a decision as to how far do you go with that. What level of detail is going to give you sort of the best value for the investment. You don't want to spend $5 for $1 worth of data. Is sort of an adage that I've heard. And so the point being is you don't want to make a model that's going to take you weeks and weeks and weeks to create and to debug and to run. If I can do something in 2 days that's going to give me 99% of the benefit of the other approach. Now, again, that depends somewhat on how much, what kind of investment are we talking about? Are we talking about building a plant for $10 million? Then there's probably a good chance that weeks worth of simulation would be worthwhile. If we're talking about moving a cart full of parts from one end of a bench to the other to make it easier for the operator to manage, or something maybe even a little bit more complicated than that, but something that's of sort of minimal cost, but maybe has a disruption cost. So I don't want to just do it. I want to do some simulation. You don't want to spend weeks and weeks on that. If I can do something in the physical sense for less cost than I can in the simulation sense, then that's the way to do it, right? But again, building a plant or rearranging a factory, those are very, very costly and very disruptive activities. So it justifies spending some time on a simulation model. So the other point too, and this is something that actually will be our, to some extent, our assignment for next week. There's often multiple ways to model, and there's often multiple ways to represent the data distributions that we're seeing in the physical sense. And it's very useful to spend some time and look at the data that we get based on several different data structures or statistical distributions that we might pick to simulate our actual process. So in the particular model that we talked about up above here, we've got a couple different entities. They're individual parts, two different types. We've got separate create modules for those two types. We've got separate process modules for each type. We've got process modules for sealer, rework, followed by a decide module, again, sort of embedded in the way they've shown that in that flowchart, but in Arena you'd actually have separate modules there. And then depart modules for ship, salvage, and scrap. In other words, those get those entities out of the system. In this case, what we've done is we have an attribute. So again, it's an entity-based thing that's assigned after the create module and the assign module. So what we've done is we've basically taken the sealer time for a given entity, and we capture that and then utilize that later in the process. So that's another useful thing. We talked about measuring queue lengths. This could be another thing. If I've got, and why that occurs, if I've got this sealer module up here, and I've got a triangular distribution for part A and a Weibull distribution for part B, and what I've got coming out of here is a finished product. I'm going to have I potentially could have a pretty good sized variation in that, and it might be useful to look at that as we process. Let me just get back to my where was I here? There we go. So it might be useful to look at that. I may utilize that sealer time in a subsequent process to make some sort of a decision based on what's going to happen to that part. And it would be, this one is again, it's using a statistical distribution. In a physical process, you may know something about the sealer time based on, for example, if the sealer time is excessive, maybe it's because the thickness of the material is out of tolerance or thicker than normal, and you might want to make some sort of a decision based on that. Then I'm going to do a subsequent inspection because I know the sealer time is longer than it should be. In this case, we're just using a distribution to simulate that, but in the physical sense, it may actually be a characteristic of the parts that's causing that sealer time to be long or short. And so I might want to make a decision based on that and then do a subsequent inspection or whatever it might be. So when we build our model, again, we just open up a new modeling window, attach a basic process manual. Normally it's there when you open it up, so it's not something you have to attach. And then you place your modules. You can use auto connect or you can manual connect. Either way, either way seems to be fine. I don't really see a big advantage of using either one. Sometimes auto connect will connect things that you don't want to connect, so then you have to unconnect them and then use manual anyway. But in any event, what we've essentially got from a logic standpoint is 2 create modules, 2 assign modules, 4 process modules, again then 2 decide modules, 3 record modules, and 3 dispose modules. So in the simulation sense, that's what logic sense, that's what we have up above there. So again, the create module, just like we had talked about, random exponential distribution, 5 minutes is my values. I call my entity type part A. The module, I call it part A arrive. So very just simple, easy, descriptive, lets me know what it is. Part B, same kind of thing. Different value, but same kind of distribution. The only difference being here, or one difference being here, I've got 4 entities arriving with each run through of the model. So then I've got my assign module, and I've got an attribute that I'm assigning. So again, attribute meaning it's assigned to an entity. and that entity is the sealer time, which is a variable or actually an attribute that I'm capturing. Again, about that entity, that sealer time changes with various entities, so I want to capture that. Similarly, I've got an attribute called arrive time, and I can capture that automatically from the system using a system characteristic called tnow, which is basically just gives you the current time in the simulation, which is useful to have. Similarly, my part B, same kind of thing, different distribution, but same idea. And again, I'm capturing that arrive time there as well. And finally, my prep process module. It's a seize, delay, release, which is very common. You've got a resource that I will assign a name called prep A. Again, simple. Quantity 1. In this case, I've chosen a triangular distribution. Again, in minutes, 1 being min, 4 being most likely, 8 being max. And then similarly with the prep B, press. Again, I've established a second resource. Important point is I don't want to, when you just accept resource, well, that's what you got. You got a resource called resource, and if you just accept that as a default in each one of your processes, it's not going to give you most likely a representative picture of what you actually have. So it's important to name those. And again, this is a place where the spreadsheet view can help you. You can click on resources, and it will tell you what resources you have assigned to what processes. So you can get a quick check to make sure that you've got what you're actually looking for. The sealer process module, again, seize, delay, release, very typical. In this case, my resource, I call it sealer. I add 1, so it's 1 unit of that, and that's defined as to how you define that resource. And that, again, is in the spreadsheet, or easiest to deal with in the spreadsheet view of your resources. And again, what I'm looking at here, this is where I'm using that sealer time. That's the attribute. So I've said my delay type is going to be an expression, and that delay time is essentially going to be the sealer time. So if the sealer time is whatever it is, that actually becomes my delay time for my process module. So in other words, the cycle time for that process module will be driven by the sealer time. And again, that's unique to each entity, or each entity has its own sealer time attribute. I mean, there could be common values, but each entity will have its own, and it's a little confusing with Arena where they call entity-based variables attributes and system-based variables variables. That's effectively what they're doing. So each entity that comes into the system will have its own delay time based on that sealer time, which was determined in the preceding process. Finally, I go to next I go to a decide module where I look, again, you can use either by condition where I'm looking at an attribute, a value of an attribute, a value of a variable. Boolean logic is used there. So if a value equals or is less than or is greater than, or is bounded by values, I can make a choice of true or false coming out of that branch. What's being used here is by chance, which means it's strictly a percentage. If I have a percentage true of 9, means 91% will be false and 9% will be true, and that will be what over time, that's what you would see coming out of the decide module. So again, the percentage thing is maybe okay to use in some applications. Typically, you'd rather look at some sort of a value of an attribute or a variable. But if you've got historical data that supports using a by chance decide module, that's fine. If historically you've got a number that says 2% of the product coming in is defective in some way, at least for the purposes of the simulation, you could go ahead and use that. That would be fine. I've got a rework process module. Again, just a process module. I call it rework process. Again, seize, delay, release. Same kind of thing. Here I'm using an expression, which is an exponential term, or exponential distribution rather, and that works just fine too. And then finally my rework, inspection, result, decide module, and this is parts that are going to be scrapped or rework. So our record modules, again, Arena collects and reports many statistics by default, but sometimes there's something you want that isn't in there. So you can establish your own characteristics of the system that you want to capture, within the system. If there's some characteristic of your simulation that's not part of sort of the standard reporting mechanisms, you can create your own. And here's a record module. And what that's being used for is to capture elapsed time up to some point in the system. So I can determine times to get from one point to another using this tnow function. It just gives you a timestamp of whatever the system time is. And then finally, my dispose modules, I'm going to collect some data from them. Other than that, all they do is get entities out of the system. That's really all they're used for. In this case, we use 3 separate part dispositions: shipped, salvaged, and scrapped. I could have sent them all through one if I wasn't interested in the individual data among the 3. If I want to actually capture in the dispose module, I could have captured it in the preceding module as well, or with a record module, which was used here. Or I can capture it in the dispose module. So it just depends what you want to do. If you want to determine values based on which path it took, then you typically would use 3 of them. Or you'd put some sort of a record module in the loop there to record the data and then dispose them out of one. Doesn't really matter too much. I think it gets you to the same place. So now, again, we're ready to run. We need to go into the setup module. We need to establish our replication parameters. Again, we've got multiple parts coming in, so replication length is probably the easiest way to do that, rather than having a fixed number of parts coming out of each create module, especially because I have 4 coming out of one and 1 coming out of the other. Got to make sure I get those units right. This is just a simpler way to do it, but it doesn't matter. It could be done either way. Set my base time again, important point. If I've got minutes here, use minutes everywhere. Pictures, again, it's just a visual. I lean towards using simple red ball, green ball, yellow ball kind of stuff that easily lets me see what's happening, but I'm not trying to show that it looks like a stamped part or a machined part or a patient in a urgent care or whatever. I just use that entity because it allows me flexibility. Okay, so again, the entity pictures, I choose to use something simple. It's pretty difficult to get something that's going to really represent the part or the person or whatever that you're sending through the process. So just using something simple like a ball, changing its color, gives me the visibility that I need. So that tends to work pretty well. So again, now we're ready to run the module. We can check it first or just go ahead and run it. The only thing I would say, which I didn't include here in the notes, is make sure you save it before you click run, because if you get an error, you can crash the model and basically corrupt the file. Rarely, but it happens. So always save it before you run it, and if it crashes, exit, don't save, and call it up again. But basically, you click the arrow, off it runs. The key point here on the control of this is the slider bar. Slow it down or speed it up. Once you see that your logic's working and that your priorities are working and that your any attributes that you're using to move things backwards. Okay, so once you get all that working, again, you can speed this thing up and let it run till the replication number or time is met, and then the animation will stop on its own. So that's running it. We talked about this. We'll go through this sort of quick, but viewing the results. Typically what you're going to look at is you're going to go right into your reports and start to look at things like, first off, you'd probably want to look at, do I have a decent confidence level? In other words, my interval half width sufficient that I can say that this is a valid simulation. And once I get that, then I can start to look at the data. And again, it depends entirely really on what kind of physical process you are trying to simulate as to what are the most critical statistics that you're going to look at. Could be queue time, could be processing time, could be resource utilization. Again, really depends on the process. And I think we've talked about that a fair amount. So again, what you would typically do, and this is sort of an example of what would happen in a commercial or industrial situation, is you'd run this and then you'd show it to somebody or present it to somebody who knows the physical process, in this case a production manager. And this individual had some comments that sometimes the sealer fails, maybe you should plug that into your simulation, that sometimes repair times can be are best described by an exponential distribution, and make some suggestions that it might be helpful to buy racks that would hold the rework queue, and a rack typically would hold 10 parts. So that gave you some very useful information. You can go back in and plug in a breakdown scenario for the sealer, and you can plug in buying racks. What that would mean is that I'm going to batch those processes, so I'd make a batch instead of doing individual parts of 10. And then you'd run that, for example, for 10 days, 16-hour days, see if you've got correlation, and then this would give you a good bit of information that is based on the physical model. And basically that's just showing how I would do that. Okay, so then what can you do? Well, a couple things. You can vary the capacity. You can see what your results are. See if they look to be reasonable. See if your outputs look to be reasonable. And if they don't, then maybe you would take a tack where you'd say, all right, well, I'm going to assume that some of these distributions aren't what I thought they were. I'm going to pick another distribution and see if I still get similar results. Another similar distribution. For example, I think in the last lecture, if I'm using triangular, change to normal. See if I get something that looks similar. Another thing we can do is define a schedule, both for resources as well as for parts coming into the system. And this would simulate things like, a good example of this would be in a fast food restaurant. They may be open 24 hours a day, but their busy times are from 7 in the morning till 9 in the morning, and from 11 to 1, and then again from maybe 4 to 6 or 7. Times other than that, there's still people coming into the restaurant, but they're not as busy. So again, the graphical schedule can be useful. Unfortunately, Arena, in the new version of Arena, they got rid of the graphical schedule, and which you could just sort of, like a slider bar almost, move your columns up and down, indicating your parameters at that time. Now you have to use the spreadsheet view, so it's a little bit more cumbersome, but still can be done, certainly. So again, a schedule is just for parts arriving, in my example of a fast food restaurant, and typically your resources would follow that. There might be a lead on that you want your resources in place a short time before the actual demand is there, but typically they would follow one another.
If I unplug it.
Okay, so resource failures, again, a couple things that you can look at here. You can program in, and many times this is the way you would do it. You'd program in two different things. One is unplanned failures, where the system, a machine breaks, whatever. So that would probably be set up with a distribution. You don't know exactly when it's going to happen, but you put in a best guess distribution to simulate that. And the other thing would be planned downtime, maintenance and whatnot. So that's a little bit easier to manage. A little easier to simulate, but also a lot easier to manage. So that is, again, what you would use for a resource. You'd want to at least put in something for a failure, even if it's unlikely, just to see how that's going to impact your system. So that's pretty much it for the lecture. What I'd like you to do for next time is, if you haven't gotten me your assignment number 2, get it to me. But then take that assignment that you've done and look hard at the statistical distributions that you've picked, and see what happens when you change those. I want to get an idea of how robust, or what I want you to do is get an idea of how robust your simulation is. If I change arrival times by 5%, 10%, what impact does it have on the system? If I've got a normal distribution, what happens if I plug a triangular distribution in with approximately the same mean and same built-in variation? It's not really a standard deviation for triangular, but a similar expected variation. And what does that do to your system? So that'll be our assignment number 3. And basically, again, take that model that's used for 2, and I want you to try to break it. See what is the most robust part of it. See which processes are most robust. See which arrival times are most significant. If you've got the side modules in there, again, bring those, you change them by 10, 15, 20%, and see what happens to your model. Now, the advantage, of course, of using a simulation package is that you can change these things one at a time to try to get some idea of impacts. After you do that, I would probably also change, if I find 2 things that have a big impact, change both of them and see what happens. So that's the assignment. Again, 2 lectures for today. We sort of make up from last time. We didn't have a lecture last week. And go ahead and take that second assignment. Again, if you didn't turn it in, and then modify it like I indicated earlier. So, okay, that's it.